Good day, students. What we are going to learn today is about covalent bonding. Covalent bonding basically involves the formation of bonds when atoms share their valence electrons. A quick recap, for example, from what you learned about chlorine being 35.5 in molecular mass and having 17 protons is usually represented this way. Now, if we are to draw the electrons in their various shells, it will look something like this. With 2 electrons in the first shelf, the second shelf holding 8 electrons, and then the remaining 7 electrons on the outermost shelf. For the purpose of this lesson, we will present a simplified drawing, and because we are only interested in the valence electrons. As such, we shall represent the diagram as this, with only the outer shelves. Now, students, in the context of a covalent bonding, this is actually what happens. A chlorine atom having a total of 7 valence electrons finds itself in lack of one more electron in order to obtain the stable octet configuration. You realize that in chlorine, there will also happen to be another chlorine atom which also have a valence shelf with only 7 electrons. In order to obtain a stable octet configuration, what they will do is they will share 1 electron each with each other. So as a result of this sharing, the chlorine molecule, the chlorine diatomic molecule is formed, and it looks something like this. This, student, is what we call a dot and cross diagram. As you can see here, this diagram is represented by dots and cross. It also clearly shows you which electron belongs to which chlorine. When this is actually drawn, we can also represent this structure in this manner. This one line here represent the formation of a single covalent bond. Now, students, when we choose to represent the chlorine atom in this manner, this is what we call a structural formula. Another way to represent this chlorine diatomic atom is to simply write it as such, Cl2, which we all usually know. And when we choose to represent this way, this is what we call the molecular formula. Now, students, when they actually share only one pair of electrons, when they share one pair of electron, what they will form is what we call a single covalent bond. Let us now consider some of the other covalent compounds that you may actually have heard of. Let us now consider the case of oxygen. Oxygen, if you refer to your periodic table, belongs to group 6. Let me now draw only the valence shelf of your oxygen. As we can see, the neutral oxygen atom lacks 2 more electrons to obtain the stable octet configuration. In order for it to obtain the octet configuration, it can share 2 electrons with another oxygen atom. And the result is this. So what happens here, in this case here, they share 2 electrons. So these 2 actually got shared. So they should no longer be there. So there you have it. In this case here, students, this oxygen shared 2 pairs of electrons. As such, they form what we call a double covalent bond. Something to take note of, students, when I mean that they obtain the stable octet configuration, it means that if you count with respect to this oxygen, it has 1, 2, 3, 4, 5, 6, 7, and 8 electrons. If we were to count with respect to the other oxygen as well, it gets 1, 2, 3, 4, 5, 6, 7, and 8 electrons. Therefore, the resultant covalent compound, which is in terms of the molecular formula, is O2. And when it comes to the structural formula, we can represent our double covalent bond by drawing this. So this is our structural formula And this is our molecular formula. Allow me to do one more example before I end this video. Let us now consider carbon dioxide. Now, I'm going to represent carbon here. Now, students, carbon is in group 4, which means it has only 4 valence electrons. 1, 2, 3, and 4. We all know that carbon dioxide is actually CO2, which means that your carbon actually forms covalent bonds with 2 more oxygen atoms. Now, oxygen atoms, like what you have seen over there, has 6 electrons. 6 valence electrons. Okay, this is O. O is for oxygen. This is not the inner circle. So students, when carbon dioxide shares electrons with oxygen, this carbon shares 2 electrons with this oxygen, and this oxygen shares 2 with carbon. This oxygen, in the same way, shares 2 electrons with this carbon, and this carbon shares the remaining 2 with oxygen. The resultant structure looks like this. As we can see here, what happens is that this carbon, they form 2 pairs here and 2 pairs here, which means the structural formula actually for carbon dioxide looks like this. It's a double bond on both sides. So this, students, is the structural formula for your carbon dioxide. Now, students, with this understanding, my challenge to you now is, after watching this video, I want you to draw the dot and cross diagram for your, this is the homework, draw the dot and cross diagram for N2. Okay? Draw the dot and cross diagram for your nitrogen gas. So this is the topic of 7.1, covalent bonding. Thank you.